Hey guys, welcome to another quick tutorial on PyTorch. So today we're going to do something very smart and very small. We're going to basically simulate a very simple neural network again. I think this is sort of a repeat of what we had done before, but nevertheless, we will give it a shot once more. So let's just get started. So let's make a neural network simulation. So the first simulation that we're going to do is as we had already discussed, X. So the output of a neural network is usually indicated by Y, and that is equal to the input, that is X, matrix multiplied by what? X star weights, that is W, plus B, that is bias. So what are the usual dimensions of X? So X has the dimension of batch size. Okay, that is the number of samples of the input data multiplied by input features. So what are the input features or numbers that we are giving to X, right? And what is the shape of what do you call weights? That is W. The weight of shape, whatever. I mean the shape of the weights W is basically the input features into output features, right? So it is basically input features, comma, output features, because it's got to match the output features, right? And then what is bias? Bias, the shape will be very simple. It will be batch size star output features, or rather comma, whatever, right? So this is basically how it is. So just to illustrate our point, let's just put batch size as 5, okay, BATCH, and then let's put input features, which is equal to, let's put it as I don't know, maybe 6 features, okay, FATURES, all right, and then let's put output features as 4, okay. So X is equal to torch dot random uh, batch size comma input features, then input features comma output features, then batch size comma output features, okay. So the output Y is equal to X at W times, sorry, plus B, right? So this is, whoops, I completely forgot. We got to import torch, okay. And let's also print X is, okay. Oh man, I put a lot of typos. Print Y is, oh, okay. So now it's importing torch, and now it's simulating the neural network. Just have a look. And as you can see clearly, it has basically given me a tensor of what shape of 5 cross 6 for the input. What are the weights? The weights are basically the input features cross the output features. Output features are around 4. So 6 cross 4, and then this is the bias tensor, and then we add it, and this is what we get as Y, as the output. So this is just a sample forward pass of a simple neural network, right? And this is what you call broad, what do you call this is basically how it works, okay. But ideally, this is not what we would do. There is a mistake in this. The mistake is, you don't actually put this as batch size comma output features. You don't actually do it. You just put it as output features usually. That's because the bias is only the number of output features. So this bias is constant. The bias is a constant. So it will be broadcasted along the dimensions. So every output value will have the same bias. Does that make sense? So that's basically what will happen. So now this would be correct, actually, in a nutshell. If you still don't understand this, don't worry. We will again go over this. But to be very specific, this is a basic simulation of a neural network, right? And what we can do is we can do something else as well. We also can do slicing, indexing, and slicing. So let's actually take an example of slicing. Okay. So I'm going to take a tensor called xx is equal to torch.tensor of maybe you're saying 1 2 3 4. um, Actually, let's put that within quotes. I mean inside, I mean not quotes, inside square brackets. And then you have like your 5 6 7 8, and then you've got like 9 10 11 12. Cool. Oops, did I make a mistake? I did. Think not do this. Yeah. Okay, so now we have a tensor called xx. Now, what is the zeroth element of this? If I want to print it out, so that should be 1 1. So I can write it as xx of 0 comma 0, right? Let's have a look. So it gave me tensor as 1. So let's say I do 0 comma 3, it should give me 3. Let's see if it does that. 0 comma 3. I mean, it is 0 1 2 3. That's why. So if I do 0 comma 1, this would give me the second position. This is because it counts from 0 1. That's how it works. So yeah, it gives me the correct value 0 comma 2, right? So this is basically picking a specific element. Now if you want to print, let's say, a row, then you would do xx of just 1. Okay, oops, I put caps lock, my bad. Print xx of just 1. So now it would print the whole tensor, the second one. So because this is 0th, there is 1, that is 2. So if I were to put 0, it will give me 1 2 3 4. Okay, so it assumes the largest dimension, okay, not the smallest, the largest. And then let's say you wanted the last column, or rather you wanted a column, right? So this is basically RO, right? This is row is this, whatever this is, this value, okay? And this is element 2 actually. Now you might be wondering, how do I pick? Not just that, how do I basically get an element, okay, that is not exactly a reference here? How do I get a specific row? Because this is how I told you to get the 0th row. Then the first row and second row, you got that part. But let's say I ask you to get a column. What would you do for a column? So the answer is pretty simple. What you would do is we just do xx of something comma, right, the column. So you're just skipping that whole thing. So I want everything with the column such that this is all, right? So now have a look. If you observed, I put the colon over here. Put the colon over here. So it's giving me correct 2 6 10. I'm giving the second column 2 6 10. This colon indicates for all. So ignoring this, you give us all. So even if we had a 3-dimensional tensor, it would work in a similar way, right? But now let's say you just want columns 1 2 3, or you want, let's say, the first 2 rows, right? So then you could do something like this, right? Whoops, shift enter. Right. So now if you can see over here, it is taking columns, but it's taking the first 2 columns, right? So it's taking 159 and 2610. Does that make sense? But let's say you don't want to start there. You want to start from the second one and go to the third. So by the index, it's 0 1, and this is 2, right? So it should be 0 to 2. So it should be 1 to 2, correct? So what we can do is we can just write 1 to 2. So what we expect now is 2 6 10 and 3 7 11. If I were to do this. Oh, okay. No, no. 1 to 2, no. I mean 1 to 3. Because you have to take the ending part, the last but one. So you would say start over here, and at index number, except index 3, but at index 3 minus that, you put this, right? If I were to put 4, I would get all of it, right? There you go. And this would be the same as just leaving it like this is the same, because this will say to the rest, right? So for now, I will leave it at 1, 2, 3. Okay. And this is how you basically slice stuff, right? And let's say we want to do a bit more, what do you call, advanced indexing type of stuff. Okay. What do I mean? I mean that you want a tensor such that you want to take specific elements in specific areas. Then what you can do is print specific elements is xx of tensor. Now there are two parts. So I want this element which is 3. So if I want that, that is in the 0th row and second column. And let's say I want 11. So that is in the 0, 1, 2 in the second row. Okay. And also the second column, because this is 11, right? So what am I expecting? 3 and 11. So will I get 3 and 11? Yes. This is what I gotta say by specific element. Um, Finally, let's actually just go by Boolean masking. Okay. So what Boolean masking does is basically it is an inequality is what you can say. Okay. So it will measure all of those and it will convert that into a tensor. For example, tensor of, okay, tensor of a value such that, okay, no, actually, you know what we should do? We should first we should first basically establish the mask. So first, the mask is equal to if xx is greater than, let's say, 5. No, let's say 6. Okay, only if xx is greater than 6, then it is a part of the mask, right? Then I can do a tensor of the mask. Okay, and sorry, not tensor of the mask. I can basically do xx of mask basically. Okay, so I can say print xx of the mask. Okay, so it's giving 7, 8, 9, 10, 11, 12. Do you see that? I could also directly write it as print, okay, xx of such dot xx is greater than some value, maybe 9 in this case, right? So that will give me all the values greater than 9. And this is another way to reference your matrix. And finally, we can also replace parts of tensor based upon their conditions, right? So let's say we make a copy. Okay, so we call it as xx copy is equal to xx dot copy. Okay, and what this does is actually we should it's not copy. My bad. It's clone. Okay, so actually what it does is it's basically clones the stuff. All right, and what we're going to do with this copy is we're going to write xx copy of something such that xx copy is lesser than 6. So you can make a bit more complex condition, right? Is bit more than xx copy plus 4. I mean, you could basically put a small equation over here and it could solve it. So for now, I'm just going to make it a very simple equation of let's say 2 star 2. Whoops. 2 star 2. So 2 star 2 is 4. So xx copy less than equal to 4. So we expect us to get 1, 2, 3, right? That is basically what we expect, right? And let's say we want to replace it. Okay, so how we're going to do this is we're going to do something a bit tricky. Okay, and I just wanted to pay attention in this one part. And if you can see over here, it has successfully actually done the condition, successfully given us 1, 2, 3. But let us say this copy that we have, right? Print, wait, x copy. Okay, let us say that all of these values of xx copy, right? One second, and let me print dash dash. Okay. So let me say that this xx copy that we have, I want to assign it some value. So let's say for all the values that are lesser than 4, I will assign the value 89. So now, if I were to print it, so now all the values lesser than 4 1, 2, 3, but it has now assigned 89. Does that make sense? So basically, we replace it in place, right? Uh, that's how we are doing it. So you can put conditional statements here as well, and you can create fun little ways of indexing and slicing, different parts. And now what we'll do is, after this exercise, we'll do a simple batch normalization example, and we will continue on. You will get more familiar with this as we keep moving forward. If it's not very good, you can leave a comment. But other than that, thank you for watching and take care. Bye.